Aloha. I'm truly delighted to join y'all today, particularly in person, because I believe there's great joy in learning together. I also mahalo Kamal and the Mini Med School team, and it does take a team, and Dr. Rosita Leong, and also Virginia Weinman, who's with us here in spirit today, and all of you students who have made it possible for the excellence of the Mini Med School to continue. This program is very near and dear to my heart, and I'm grateful to all of you. Now, my topic today is pandemics. Appropriate cartoon there, Kamal. Past, present, and future. And we're going to talk a little bit about the progress, but also the challenges that we have to face in the future. Now, first, I want to talk about the path to a pandemic. And these are some of the terms I'll be using. Endemic. That means in people. It means it's around all the time, circulating. And we have a lot of viruses and infectious agents of all kinds that do that. Certainly now, COVID-19 has become endemic in people. The term in animals is enzootic. They have the same thing, so we have to consider them because they're very important in the diseases we get. Now, you can have an outbreak, which is a greater than expected increase in cases. Remember measles, when people weren't vaccinating their children? That was an outbreak, and you try to quickly get on it so it won't become an epidemic, because it certainly can be. And that's where you have a large number of people in a community or a region, and epizootic happens in animals. Now, pandemic, that is all people, and that's what it involves. Populations all over the world. And we also have panzootics in animals as well. So those are some of the terms I want you to think about. Now, to be a pandemic, or called a pandemic, you have to have certain criteria. Certainly it's global. It's not local, it's global. A new infectious agent that appears or emerges in the human population causes serious disease and death. And this last one is the most important. Spreads easily person to person. Needless to say, COVID-19 met these criteria in a big way. And I'll tell you about one that has not done this, but one that we're watching very carefully. The H5N1 highly virulent avian influenza virus kills birds, 100% of them typically, and kills 50% of the people it infects. Now, it takes close contact to catch it, but the one thing it does not do is spread easily person to person. But there's a panzootic of this in birds right now throughout the world, wild and domestic. So this is one we're watching very carefully, because if it gets that capacity, it is going to be a severe problem. But so far, we haven't had that problem. Now, what pandemic is often meant as a passport for an infectious agent. They can come on in, they can go to any country, and they certainly do that. We've seen that clearly with COVID-19. Now, there are actually 259 recorded pandemics, but I thought y'all wouldn't want me to go through all of them. Not today. So I picked the biggest killers. And these are the ones that have caused the greatest number of deaths in the world. Cholera and bubonic plague, those are bacterial diseases, and smallpox and influenza, viral diseases. And remember, there's a big difference between bacteria and viruses. Bacteria can make more of themselves sitting here on the table. They have their own unique metabolism, and antibiotics interfere with that metabolism. Viruses, they need our cells to make more of themselves, so they're using our machinery to reproduce and spread. That's much more difficult to design antivirals, and antibiotics have no effect on viruses. So that's an important distinction to keep in mind. Now, the first one, cholera, by the way, all of these are really old. They've been around for centuries. These are not new diseases. This one is one example. It had caused 6 major pandemics, and it's actually a really cute little bacteria. It has a little tail or a flagellum. It helps it swim through the water, which is helpful to it. Now, the disease, the worst one was probably in the 1800s, and this had a very high death rate. What happens is this is called the blue death. Let's see, I get to work this new little thing they have, the blue death. And the reason it's called that is cholera induces very severe diarrhea. So they get dehydrated. Their blood thickens and they can't carry sufficient oxygen to the tissues. So they turn blue or cyanotic. And that usually means they're going to die. But thankfully we had a hero here, Dr. John Snow. He was a London physician who was one of our early epidemiologists. He was intrigued with finding out where these were going. When you saw an outbreak, can he track it back? And so he tracked all the cases around London. And what he found is the culprit was the Broad Street pump. And what had happened is people who had cholera, their feces had contaminated the water in the pump. And so he shut down the pump and it stopped the pandemic. Now, clean water has always been a huge issue for health and well-being, by the way. Now, this is very rare in industrialized countries today, but it is endemic in other countries. And we see outbreaks in Africa and Asia, but we are not concerned about a future pandemic. So this one is off the list for pandemics. And we see, over 1 to 4 million cases a year. It's not like it's gone, but the treatment is so direct and simple. Hydration, IVs to replace the fluids they've lost from the diarrhea, and antibiotics. So this is a controllable disease. And of course, we want to prevent it. And the way you're going to do that is clean water and good sewage systems so that you don't end up with a contamination of the water. And this is certainly possible. They do have vaccines, but we don't use them in most countries because it's just too rare. So this is one that's really kind of basically gone. The next one's bubonic plague, and this one caused 2 major pandemics, but it caused 75 to 200 million deaths. So it's highly toxic. Yersinia pestis is the organism that causes this disease, and it's been around a very long time. Now, this was called the Black Death, and this is a plague pit where they used to just put hundreds of bodies every night because so many people were dying. Killed 30 to 60% of all Europeans. So that was huge. And the reason it was called the Black Death is people develop clots in the tiny vessels, and they get gangrene in their fingers and toes and extremities, and then that turns black. In addition, they bleed under the skin and get black spots. So this was a terribly tragic disease in many ways. And this was your physician. This is your physician here that would come see you. Wore a hat, a hoodie, a leather mask that looks like a bird, a long coat and gloves, and also carried herbs and potpourri around with them because they thought it was bad air that was causing the disease. They were wrong. It wasn't any protection because the culprit are rats and fleas. The rats had the organism, the fleas would bite the rats, and then they would transfer to people. And this was particularly common in sailors. And they noticed that ships that were coming in, they were having death and destruction from the Black Death when they were around. So they called those death ships, and I think it was Norway that first started quarantining them. They would make them stay way away from the shore for a month before they'd let them land. And the reason, they wanted to see if they were dying. And then once they quarantined the ships, the pandemic stopped. Okay? Now this one, we still have it. It's in the US, but we only have like 7 cases a year. And you notice the location of where it is. It's out west, and that's the reason because it's in rodents. Everything from prairie dogs, squirrels, rats, voles, and then anything that eats them. So we do have cases of it, but it's typically more in scientists who are working with these animals to study those populations. My granddaughter, Audrey Virginia, she lives in Denver, and she lives in horror of her dogs chasing prairie dogs. And she's right, because they do have plague. Now, it's rare. in people in the world. We don't have a lot of cases, only 1,000, 2,000. It is enzootic in wild rodents, everywhere. It is all over the world. Plague is not going away totally, but it's all over the world. But, again, the treatment, antibiotics, and isolation of the patient so their fleas don't get on other people. So it works. So prevention, people can reduce rodents, but of course you can't reduce the wild population that much. They tell people to wear gloves of handling them, flea repellent, and there are vaccines available, but we do not use them in the U.S. because you would not do that for 7 cases a year. So that one is also off the list. So 2 out of 2 now, and this is smallpox. Now, this was one of the biggest killers, and this is Pharaoh Ramses V, and he had pop marks on his face as a mummy. They could tell he'd probably had smallpox. So it's been around a very long time, and it's devastating. 300 to 500 million deaths in the 20th century. Not that long ago. It was really costly. And I mentioned it's an early bioterrorism agent. The U.S. Cavalry used to rub smallpox scabs in the blankets they gave to the Native Americans. And this was to incapacitate them so they could defeat them more easily in battle. Not a pretty story. But you can see the intensity of this disease. It's really horrible. And this is a virus. It's a great big virus, a DNA virus. And it's very severe disease. Now, we have a hero here, too. In this case, Dr. Edward Jenner, who was a country physician in Britain. And he noticed that the city women all had pop marks on their faces from having smallpox, because people did survive, not as many of them as we'd like. And then he noticed that the milkmaids had beautiful skin. And they also would get little pop marks on their fingers from milking the cows, because the cows would have these little lesions on their udders. And that's actually cowpox, a relative of smallpox. And he started putting these two together, that, well, maybe they're protected against smallpox because they didn't get smallpox. So he took scrapings off of one of the fingers, seronilms, and he vaccinated or scratched the skin of this young boy, Phipps, James Phipps. He did something that we would not do today. He challenged him several times with live smallpox. And he was protected, thankfully. And this was the beginning of the vaccination. And it had worked beautifully, but it was a very unusual start to how they put all this together. Now, this is what the smallpox vaccination scar looks like. How many people have one? Okay. If you ask a group of students, they say, what? What does it look like? Don't think I have that. No, they don't. And that's marvelous, because what happened is we eradicated it in 1980. And I love this statement: the world and its peoples have won freedom from smallpox. So there will be no future pandemics. But now there was a very unique situation. This virus, it doesn't change. It's very stable. It's only found in humans. Plus, they have a great vaccine and a world that cooperated. That was the key. The whole world had to spend money, time, and effort to eradicate this disease. You can't eradicate it in one country and then expect you won't get it again. So it was a magnificent event. And also, this same vaccine was used against monkeypox more recently, because they're closely related. So they were using that to prevent the spread of monkeypox in the world. But this was quite an accomplishment. It's unbelievable in my view. So there will be no pandemic, we figure, from this virus. So 3 out of 4 is not bad so far. Then we get to my favorite, influenza, which I spent many years studying, which Hippocrates first described as a disease. And it's been around a very long time. It's around. And many of us may even have relatives who talked about the 1918